Hi everyone, thank you for joining our session. My name is Neeraja Rentishintala. I lead the product management for Amazon Redshift.
Hello everybody, my name is Hippocrates Pandis. I'm a distinguished engineer at AWS and I spend a lot of my time with Amazon Redshift. And Amazon Redshift is Amazon's cloud data warehouse. It was the first cloud data warehouse. We launched a bit over a decade ago. So we have an experience of 10 years.
Since then, tens of thousands of customers have been using Amazon Redshift for all their analytics needs, collectively analyzing exabytes of data every day. We have been innovating on Redshift for the past 10 years by closely listening to our customer needs on how their use cases are evolving, both on the data as well as on their consumption. So what we really see is that a modern data warehouse is not really a silo anymore. So our customers has been using Redshift for traditional data warehousing needs like high performance business intelligence and analytics, but they don't just stop there, they go beyond. They use it for petabytes of data across tens of thousands of users and make it available in a self-service fashion. They use it for machine learning, opening it up for Spark applications. They use Redshift to query open data formats in their data lake. They bring their streaming data, operational database data, trying to do near real-time analytics. And in the last couple of years, we are seeing a lot of traction around data sharing, where they're trying to share data within and across their organizations, live data, collaborating with their entire business ecosystem. So when it comes to innovating in Redshift, we really think about it in two buckets. The first one is around core data warehouse pillars. So these are things like security, availability, performance, elasticity, autonomics, etc. And on the second bucket really is around how Redshift can be deeply integrated with rest of the AWS services so that you can actually do analytics on all your data and make it available for all your users.
And let me tell you a few things about how we think about the core pillars of data warehousing. If you squint a bit, our efforts on the core of the system are focused in 5 thematic areas. The first one, and probably the most important, is security and availability. Our tens of thousands of customers trust us that we're going to manage safely their exabytes of data and give access to them to this data in highly available fashion. And if we have to choose, actually, between security and availability, security trumps everything else. And we are very happy with the security capability features we are giving to our customers at not additional costs. We offer capabilities both in terms of authentication and authorization, the things our customers can do, such as role-based access control, without having, we get very positive feedback from our customers. And the latest security feature which just recently launched was the introduction of dynamic data masking in Redshift. As you can see from the quote on the left-hand side of the slide, our customers are already giving us very positive feedback. They can elevate their security postures to their own customers, and we are excited with that. On the availability front, one of the latest innovations we did in Redshift was the introduction, currently under preview, of Redshift multi-AZ Redshift, which what we do is we are running 2 compute environments in 2 availability zones, and if there is any issue, in the rare case that there is some availability issue on a computing environment in one of the availability zones, we switch to the other environment. And when things are working fine, both of these environments are in an active situation, contributing to the performance of this environment.
The second pillar here is performance. So with performance, in Redshift, we focus on providing high performance for the queries. But when you think about data warehousing, you really have to think about price performance, which is what is it costing you to get that performance? Because in cloud data warehouses, it's very easy for cost to explode in your attempts to really get good performance out of the system. So with Redshift, we offer up to 5x better price performance compared to the alternative cloud data warehouse systems. So as you can see on the right-hand side here, the benchmarks are done using industry standard benchmarks like TPC-DS and TPC-H. And in fact, you can just try this out yourself from our GitHub, the Cloud Data Warehousing Benchmark, and run your queries. So price performance is a really important criteria for us. Ipo, do you want to walk us through a little bit more about the technical details of performance innovations?
Sure, that's what I like to do. All right. If you, in order to understand how Redshift works and how to achieve its good performance, we can look a little under the hood. The Redshift database consists of two layers, the compute layer and the storage layer. On the compute side, we have two different types of nodes that operate for the customer. The first one is what in the slides you can see is in a green box, it's the leader node. This is the entrance for the customers to the system. This is where customers go, connect with their favorite tool of choice, and they submit requests to the system. And then there are the bunch of compute nodes that are the workhorses. They are responsible for executing very fast those statements. When a request comes into the system, it goes through the regular query processing lifecycle. So it gets parsed, it gets rewritten, logically rewritten in order to get something that is equivalent but faster. And then we check on the catalog, we get the statistics, and we generate a distributed query execution plan that we believe that it is optimal to execute this statement. Redshift has some very nice properties. The tables, for example, you can define something like a distribution key, and if you are joining a customer's table and an orders table, and the orders have the customer ID, and you are joining them on the customer ID, they are distributed on the same key, so you can join these tables without having to shuffle data, and this is a very efficient way to process data. And then one thing that Redshift does, which is kind of unique in the industry, is that after we generate this physical query execution plan, we open a file and we generate C++ code, almost handwritten C++ code that is very efficient, and we compile it, and we send it to the compute nodes, and we say, okay, go off and start executing this query. Then the individual compute nodes take this executable and then start scanning the data they are assigned from the managed storage. And we use a lot of very smart techniques there. We prune blocks while we're processing. We use vectorized execution in order to make efficient use of our processors. We use proprietary encodings. By now you are almost an expert in how to build a distributed parallel database, a very efficient one, such as Redshift. And we keep on innovating in the cloud. For example, when I have this kind of talking about that, always somebody in the audience says, don't you worry about the cost of compiling code at runtime while you are doing this processing? And the answer is obviously yes, we do worry. When in the old world where data warehousing was considered an offline process where you would load the data at night and run some reports that would take minutes or hours to complete, the cost of compiling this code was negligible. As we move now to more near real-time workloads that have more concurrent users, that have lower expectations for lower response times, this overhead of potentially compiling code becomes more of a problem. We do a lot of tricks. For example, even just by putting a small cache on the leader node of every computing environment, we are able to avoid recompiling code at 99.5% of the cases. The reason why this happens is because there is a lot of repeatability. Customers go and submit the same query potentially the next day, same query, same report, you refresh your dashboard, you run pretty much the same kind of questions. That was happening for Redshift for a long time. But even this 0.5% of the queries that had to compile was potentially an opportunity for us to improve. So the next thing we did is we took that to the cloud. We took advantage that we run in a cloud environment. And now every time we see a new segment of code that we have not seen before in the fleet, in the billions of queries we run in the service every day, we push it to a centralized compilation service that we offer without charge to our customers. And we have a farm of machines that go compile the code offline, publish it in a global cache. And now if this environment or in any other environment of Redshift across the globe wants to run pretty much the same type of query fragment, sees this thing without having to recompile the code. And by doing this trick, by taking advantage of the fact that we are running in a cloud environment and we are running billions of queries every day, we were able to improve the cache hit rate from 99.5% to 99.96%. And this is a very nice trick you can do in the cloud you could not do in the traditional on-prem warehouse systems. And we keep on innovating in this space. Once we achieved this pretty good performance with Redshift, the next thing our customers asked was, okay, we really like the performance of Redshift, but we would like to be able to store more data in the system and be able to have more concurrent users using the system. Can you please do something about it? And that's what we did. Probably the biggest innovation we have done, the largest architectural change we have done in Redshift over the past 10 years was the introduction of Redshift Managed Storage. Prior, Redshift was the storage and the compute were co-located. One of the reasons was that networks back then was not very, the bandwidth was not very high. But with all the innovation that our friends at EC2 are giving us with the Nitro platform, they are offering us high network bandwidth, we were able to separate storage and compute, and now being able to scale those two layers independently. This is one of the slides that I am very proud to present, even though it might sound boring, but what we did in this experiment, we started running a standardized benchmark called the TPCDS, and we started running from a small data set of 10 terabytes of data, and we scaled it up 2 orders of magnitude to 1 petabyte of data. And what we did, we also scaled correspondingly the compute side of that. And what you can see is that the amount of time it took us to run this benchmark took pretty much the same amount of time. Well, you will tell me, oh, boring, this is what we expect a system to do, but required a lot of engineering to be able to scale linearly the performance of a system by 2 orders of magnitude. That means that customers, that they have this predictability. We did 2 main things. The first one we did is we allowed to online elastically resize the size of every individual Redshift compute environment. So with the press of a button, you can increase the size of a Redshift environment by up to 4x up and 4x down. So you have a spectrum of 16x of sizes where you can fine-tune to pick the proper SLA for your queries, to fine-tune the performance of individual queries. And once you find that, there will always be this Monday morning that all the analysts go, they drink their coffee, they submit their request, and they want to see, the results. And at this point, there will be, a burst of requests coming to the system that you need to do something about that. In order to address this need, we implemented the ability of Redshift to auto-scale, what we call Redshift concurrency scaling. What concurrency scaling is doing is literally an auto-scaling capability. So the requests are still being submitted to the same Redshift endpoint, and if we see that we are running out of resources at the main cluster because it is doing so much work, we go and we pull another equal-sized cluster from a pool, and we start running workloads there, and when the burst of activity comes down, we go and contract bound back to the original form. And I think you have seen that this thing works pretty well.
Yeah, so we have seen the price performance benchmarks before for an individual workload, but as Ipo was talking about all the scalability, this performance needs to scale. So this is the graph that you see on the right side here on the slide really represents a real life workload. So where a customer has a dashboarding application, these are very, very small queries, very high concurrency. So in these situations, as you can see here in the benchmark, Redshift offers up to 7x better price performance compared to the alternative data warehouse systems. But the bottom graph, what it is showing is the ability to scale linearly. The key is linear. So if your system is not scaling linearly, again, your costs are not predictable as your needs are growing with more users and more queries. So it's important that it's not just getting price performance for individual workloads, but get it at scale and scale linearly. And as the needs of the customers they started accommodating a lot more data, a lot more users, what we started to see is a demand for isolation, the workload isolation and chargeability. So what our customers started doing is, to accomplish the isolation, they would split the Redshift into multiple clusters. So they put the data, for example, they have their ETL or data processing in one cluster, and then they have their business intelligence, data science, dashboarding type of workloads in other Redshift data warehouses. And then what they have to do is basically move the data from one Redshift data warehouse to another. So the next innovation that we have done is data sharing. So data sharing allows customers to share live and transactionally consistent data across multiple Redshift data warehouses without making any data copies or data movement. And you can have, so in this ETL, the example that I was giving, you can have a centralized cluster that is bringing the data, that is doing processing of the data, but it is opening up to many business intelligence clusters. One could be running your executive dashboarding application, another could be running your machine learning, and another could be your ad hoc type of workload. But all these clusters, they can individually, they can be sized individually for according to their own performance requirements.
And they can auto-scale. Yeah?
And they can now they can auto-scale. So we talked about how as more and more users come in, the system can automatically scale. The beauty is data sharing and automatic scaling are complementary features. So for example, if you have the dashboarding application where you have morning 9 to 12, a lot of user activity, and in addition to the data sharing, this particular dashboarding data warehouse, it can automatically scale to accommodate the spike of the users. So one capability we are very excited about data sharing is available within an AWS account, across AWS accounts, and also across AWS regions. So what this allows you to do is really have a distributed global data mesh architectures of Redshift data warehouses that are seamlessly sharing data, collaborating on common data sets. This is very powerful, and this is what we see customers adopting more and more in order to kind of decentralize their environments, and but still not bottlenecked by centralized IT environments. So we didn't stop there. So data sharing is very powerful. We took it to next level. We integrated with AWS Data Exchange. AWS Data Exchange is a marketplace environment where subscribers can come in, they can find the data, they can subscribe to the data. So what we have done is took Redshift data and actually made it available as products on AWS Data Exchange. So if you are a data producer, you can just take the data in your warehouse, make it available as a data product that you can license and monetize to third-party consumers. And similarly, the subscribers can come in if they are looking to consume third-party data and enrich it with their local data. All they have to do is just subscribe, come in, find the data set, subscribe to it, and start querying within seconds. So there is no data movement. This is all live data sharing. This is powered by live data sharing. And the AWS Data Exchange handles all the subscriptions and the payments and the licensing aspects. So as a customer, you don't have to kind of worry about how do I subscribe to it, how do I pay for it. This is all taken care of. So Orion is a great example using Redshift data sharing. So what they do is, Orion, first of all, is a company that is that shares data. It's a real-time data as a service offering organization, and they share financial data, share data to financial providers. For example, for asset management or wealth management, investment management providers, and they have over 2,500 plus data sources. Some on premises, some are on AWS. And all this data comes through Kafka into Redshift central clusters, and from there they share it to other their customers. This is all live collaboration powered by data sharing. And the very nice thing is this is a complete multi-tenant architecture. So they are able to achieve the security and the isolation that they are looking for using Redshift data sharing. So I think one important thing is, as you can see, the needs in the organizations are growing. They're able to scale, make it available for all users in the organization. So it's not possible for a specific like one DBA or a very small database team to really predict the workloads that are going to come from all these users, all these use cases. So we started innovating a lot on how do we make Redshift self-optimizing? How do we make it like an autonomous database? Ipo, can you walk us through a little bit on the autonomics innovations?
Happy to. All right. So as customers come and they use their Redshift environment, they will be opportunities during the execution lifetime, that there will be some spare resources that we can take advantage of. And that's what we do as we run something as a service in the cloud. We continuously monitor, actively monitor what our customers are doing, and we have a bunch of activities, maintenance operations that previously used to be a responsibility of the database administrator to do, and we kind of take over and we do them ourselves. So we kind of see what needs to be done in the system, and we say, okay, it seems to me that I need to go and analyze this table because the statistics are required to be updated. I need to vacuum this table, or I need to even go and make changes in the physical schema of the database because I think that with the patterns of usage I see, it would be better for me to go and change the physical schema in order to improve the performance. And we do that in a very active fashion without requiring some DBA to go and issue commands to do that. And the system just gets better. So this is one of my favorite graphs we have generated in the lab, where what we did is we were running a standardized benchmark, started running this benchmark called TPCH, and what we did is we just defined the logical schema of this database, of this benchmark. We defined the tables, we didn't do any tuning, and we start running this workload. And you can see that over a few hours, after some hours, the performance of the system improved by almost 2x. From where it was taking 100 minutes, in a few hours, it was running in 60 minutes, without the customer having to do anything. And what happened was that the system was actively monitoring, was seeing what the customer was running, and essentially changed the physical schema of the database in order to improve performance. And now we're taking that to the next level. The next innovation we're excited about was that not only we're changing the physical schema of the database, like changing the distribution key or sort key or something like that, but we are going even and we are going and automatically create materialized views. So if, for example, say you load the data and 9 o'clock every morning you run this report and we feel that this is the right thing to do, we may go and decide to create pre-create essentially a materialized view to answer these queries immediately, without the customer have to wait for this report to be generated in line when the customers come in the morning to submit their queries. And if we see that this materialized view is being not used, we go and drop it. This very active monitoring and involvement and dynamic change of the configuration of the system and the database is something that makes it our customers find very, very useful. And I would say the culmination of all these efforts was the introduction of Redshift serverless.
Serverless, we are very excited about Redshift serverless. So this is launched as GA last July, so it's been 9+ months. With serverless, so the way I like to think about serverless is with Redshift data sharing, we have simplified the data management side of things. So you don't have to worry about moving the data, copying the data, managing all the silos of the data. With serverless, we have completely simplified the compute side of experience. So with serverless as a user, you would just come into Redshift and you don't have to think about node types, node count, configuration, you just start doing queries. You just need to pay for the duration that the workload was running. So pay for use is very powerful when it comes to kind of the variable ad hoc style of workloads. And it's been, as I said, only 9+ months since the serverless is launched, but we have tens of thousands of customers already started adopting and putting serverless in production. These are some examples, what you see on the screen here. The main thing customers really like about serverless is its simplification. The fact that they don't have to manage anything is really a game changer for them. And the second aspect they like it is as they start using it more, the system automatically scales and maintains the performance. And last but not the least, the pay for use, where they can actually save on data warehousing costs, is very powerful. So we have continued to add a lot of capabilities to serverless since the launch. So these are some examples like support for tagging, single sign-on support, monitoring improvements, price performance improvements.
I want to say that the entry point now it's just 8 RPUs.
Yes. So this is a big deal. So with serverless, really what you're trying to do is onboarding new workloads, opening it up for like your development test environments. So we have reduced kind of the entry point to 8 RPU. RPU is Redshift Processing Unit, so it's much more kind of a lower price point for you to start experimenting and start adopting Redshift serverless. So we talked about the core data warehouse pillars. The second bucket, when we think about the innovation with Redshift, really is how Redshift integrates with rest of the AWS services ecosystem. So Ipo, give us an overview of Redshift integration with other services.
So in the first part, I kind of we try to kind of make a case that the core of the Redshift database warehouse is a very high performance, scalable, secure, and available environment. And with that, now our customers can go and build a very flexible data mesh architectures. So that is kind of the core of the system. The next area, as you said, was we want to, on the one hand, we want to make it very efficient and easy for our customers to load data from the various data sources. Be it files that live in S3 and we auto-copying them now into Redshift, be it operational databases or streams. Kinesis and Kafka are the message buses of any modern data application, and we have ability to do streaming, to ingest the data in a streaming fashion from these sources.
And even third-party data.
Yes. Yes, and and then you can go. You have your own. You can have third-party data, and you can pull them into Redshift, in your Redshift environment. And then on the other hand side, we want to democratize or open up the analytics for various classes of users. From giving access to Redshift from BI tools such as QuickSight and Query Editor, to be able to run machine learning, either directly from Redshift with Redshift machine learning, or even use Spark, and you can say SageMaker, use Spark, and you can run efficient Spark applications on top of data.
A very important thing to highlight here is, as we are integrating with all these AWS services, a key part is connecting this kind of services. We find that customers have to often build complex ETL pipelines. For example, if you are trying to ingest from streaming services, you have to build a pipeline. If you're trying to ingest data from operational databases, you have to build pipelines. So as we are thinking through this different services and how Redshift integrates with it, what we started kind of thinking about is a zero ETL kind of a future, right? Both on ingestion as well as on the consumption. We don't want customers to really have to manually build and manage pipelines. That entire integration experience should be completely smooth.
Yes.
So some of the capabilities around zero ETL we are really excited about. The first one to highlight here is Redshift streaming ingestion, which allows you to bring data from streams. This could be Amazon Kinesis or MSK, Managed Service for Kafka. So either of these systems, you have streaming data come in, and it is now very, very easy to ingest this high throughput data into Redshift and start analyzing it within just few seconds, near real-time analytics. And then the beauty is that the work that you need to do here is literally nothing. Basically in Redshift, you just have a materialized view and it points to a Kinesis or Kafka stream, and that's it. As new data shows up on the stream, the data is automatically showing up in Redshift, and it gets continuously refreshed. So you're always looking at live data.
Yes, and you can even have materialized views on top of this materialized view, and you can, for example, if the data is a log or a JSON, stream of JSON documents, and then you can go and create
additional materialized views. So that is very powerful. So I think this makes customers like move into different types of patterns, like such as ELT. So where they're bringing their raw data, bring it into Redshift, start analyzing it for exploration type of queries, and then do the transformation on top of it using materialized views and other powerful SQL semantics that Redshift offers. So streaming ingestion has been a very, very popular feature with our customers. It's been only 5 months since it's GA, but we already have more than 1,000 customers that are using it in production. The next capability, which is in the zero ETL. So we talked about ingesting from streams. We also simplified ingestion from files. So if you have data continuously landing in Amazon S3, now it's much more simpler to bring that data into Redshift using the Redshift auto copy from Amazon S3 feature. So this is a very simplified automatic file ingestion capability. All you need to do is specify your source S3 bucket, your target Redshift table, and Redshift automatically detects the new files that are landing in the S3 bucket, and it would continuously ingest data into Redshift. So if you think about it again, there is no pipelines that you have to build and manage. This capability is currently in preview, and you can try it out.
And the third one, which is one of the I'm personally very excited about, has been how we integrate, one integrates with operational data stores. Say you come with your favorite MySQL or Postgres application. In order to move this data into a data warehouse, you have to go and build a pipeline that might require a bunch of steps of transformations in between to enrich the data and do all sorts of deduplication and things like that in order to move the data from the operational store to the data warehouse. That adds some latency and also adds some operational overhead for our customers to make sure that these pipelines are working. And for that, we are very excited that, and we will partner with our friends at Amazon Aurora, which is Amazon's best-of-class operational data store. We have Amazon Aurora, MySQL, and Postgres, and we are now in preview of Zero ETL. What it does is it offers an easy, secure way to offer near real-time analytics of your data that live in Amazon Aurora. And the way we did it is we worked with our teams from the Aurora side, where what we did is we integrated at the storage layer. This is something that if you were in a traditional integration way, we were not able to do. So we have the Aurora storage, and we found a very efficient way to move the data in from their row-oriented operational store efficient way of storing the data to the analytics optimized format in the Redshift managed storage. And we offer all sorts of observability tools on top of that, so customers can know what's going on, and they can offer now architectures that one endpoint does the very efficient operational workloads, and on the other side they do very efficient analytical workloads on the same data sets.
And the user experience is very simple too.
Yes.
Right? I think this all, as a user, you just have to create this integration object, which is a new kind of abstraction, and you just specify your source as your source Aurora cluster,
yes,
and your target is Redshift data warehouse. And again, that's it. You don't have to do anything else. No pipelines.
And in this case, we have heard multiple customers being excited about is they come with a multitude of Aurora databases, say one database per marketplace they are operating on, but they still want to run analytics across all these environments, and they're able to do this hone in one endpoint of all their live data and run analytics on that. And the other area where, now on the consumption side, one thing that we are excited about has been that we're able to bring machine learning capabilities on your live Redshift data. So we have integrated with SageMaker, which is our Amazon's state-of-the-art suite of machine learning tools. And what we have done is we offer the ability within SQL, without getting out of Redshift, to be able to train models of your data. So in the slide you can see an example where a user can go and create a model based off of some selection of some Redshift data with some filters and whatnot. And not only train models and publish them, but also being able to consume this model as a scoring function or as an inference function. And the way they appear on the consumption side is they appear as SQL functions. So you can do select, name, comma, scoring function of probability of this customer to buy or not buy some product. And actually, under the hood, the way we do it is very, very interesting, right? We have integrated with SageMaker Neo, which is for many of the models we have. Neo generates C++ code that it is very efficient, and as I told you earlier, we generate C++ code to run on the queries, one of the main ingredients of how Redshift is fast. So we kind of link also this executable, so we make inference very efficient, above and beyond other engines can do.
And if we didn't have the Redshift machine learning capability, a customer has to manually move the data. If they have all their data in Redshift, and if they have to train their model, they have to unload the data to S3 and then train it and then shuttle the data back into Redshift. So there is a lot of data movement that is needed. So again, this is kind of a zero ETL in the context that you are able to do machine learning by keeping the data in place, trying the data, run the inferencing, everything without having to kind of move between different stores.
Right.
Yeah, so another key initiative we have done from a consumption point of view is Redshift integration with Spark. And now the good thing is customers, like users, these could be data engineers, data scientists, developers, they can come and build Spark applications directly on top of the data in the data warehouse. And previously, if you had to do something like this, essentially you would download an open source Spark connector, you would manually configure it, and you would set it up to work with Redshift, and then an ongoing kind of fashion, you have to maintain that particular connector. So what we have done is really make this simple so that you can get started quickly, whether you are using Amazon EMR or SageMaker or Glue. Now you have a fully packaged integration that is available for you, and you just have to work with these tools and start accessing and building Spark applications very, very easily. And a very important thing we have done is we have improved both on the performance and the security side of things. The performance, for example, if you think about like Redshift has a petabyte of data and your Spark application is processing probably a few gigabytes or a few terabytes of data, we don't have to bring all the data over the network now. So with the advanced push down capabilities that we have, we are able to push down kind of the filter operations, aggregation operations, join operations, so that you are just bringing only the necessary amount of data in order to run your Spark application. So again, this comes fully packaged with the Amazon EMR 6.9 version onwards and Glue 4.0. So you don't have to do anything. You just have to kind of start building your Spark applications.
And that's where we are. We now, 10 years later, we're here. We have tens of thousands of customers using Redshift. They process exabytes of data daily using Redshift. We are offering industry-leading security and availability features at no additional cost. We are very focused on providing the best price performance in the industry, so that our customers can do to get the most out of what they are paying for, and don't have unnecessary expenses. We innovated with separating storage and compute and introducing Redshift managed storage, taking advantage of the Nitro hardware, and now we have the ability to store petabytes of data within one Redshift environment and have thousands of concurrent users using Redshift on the same endpoint. And then we innovated on the autonomic side. We kind of took care and took responsibility of all these mundane maintenance operations that previously were responsibility of database administrators. And all these things led us to introducing Amazon Redshift Serverless, which we have heard very, very positive feedback since summer when we launched Redshift Serverless. We are tightly integrated with the set of AWS services such as Kinesis and MSK streams, such as the operational databases, and probably more importantly of all, Amazon S3. S3 is the backend where we store the Redshift managed storage, but also we have exabytes of data in open file formats in S3, which we give access to our customers through the capability of Redshift querying data from the lake. And then on the consumption side, we have integrated with SageMaker. We have offering machine learning capabilities as well as the ability to run efficiently Spark applications on top of Redshift. And with all these things, we give the ability to our customers to build modern data applications based off of data meshes on top of Redshift. And it is still day one, as we like to say at AWS in Agile. We're excited where we are now with Redshift, and the foundations, the performance, the scalability are there. And who knows what we're going to, and the innovation is there. We're excited with all the stuff we have with Amazon Aurora integration with Zero ETL. And who knows what we're going to talk about next year. Probably we'll be here and presenting some more stuff.
Yeah. And by the way, you can try out Redshift serverless. We have a free trial that comes with $300 credit. If you are new to AWS, you can use that credit and apply towards your kind of first attempts with Redshift. With that, thanks everybody for watching. We really enjoyed speaking with you.
Yep.